Good afternoon, class. My name is Timothy Fukuyama, and this is my LBCP presentation for Module 1.4. One of my proposals is a bit more far-fetched toward the sci-fi side of things, but the other one is definitely more in the realm of possibility in the near future. As for my interest in space launch, I've always been fascinated with space research and discovery, even as a small child. Some of my favorite books given to me by my parents were all imagery from both Earth and space-based optical telescopes. Even now, I'm fascinated by the endeavors to improve our understanding of the universe around us, near and distant. It's no surprise, then, that I eventually got into owning my own telescopes many years ago, specifically with the intent of taking photos of the cosmos. This led me to having various relationships with local astronomy clubs and participating in public outreach events. One of the most rewarding aspects of those events is seeing a kid look through the eyepiece, yell, "Whoa!" and then immediately run back to the back of the line for an opportunity to look yet again. Ultimately, this convinced me that I wanted to have space in my career as well, so I made the jump over to Army Space Operations. I absolutely foresee a reduction in the cost of future launch operations. The data shows that commercial competition has continued to drive prices down, especially in the heavy lift market as companies continue to develop reliable vehicles in that particular area. Additive manufacturing is pushing performance to new levels while reducing production costs for all mechanisms in the space launch continuum. Further increasing performance, new alloys have allowed for higher chamber pressures and heat resistance. As for the demand aspect of space launch, the growing number of mega constellations and enticing new competitors into this sector of launch. My first concept is the extremely experimental one I mentioned in my introduction. Orbital Rendezvous and Centrifugal Assist, or ORCA, is more of a post-launch assist to customers with an existing means to get to LEO. After an orbital rendezvous with a centrifugal assist station, a sliding counterweight is utilized to match the mass of the craft intended for a slingshot into deeper space. The target spacecraft would produce minimal lateral thrust to induce a rotation within the station. Then, much like a figure skater bringing in their arms, the station would retract both the spacecraft and the counterweight toward the center of the station, drastically increasing the ship's velocity. At a specified calculated moment, the spacecraft is released and slingshotted to its far distant destination. Naturally, this would only involve unmanned probes, primarily meant for deep space research or potentially asteroid mining surveys. The use of the centrifugal assist would reduce the cost of distant transfer orbits and preserve fuel for the deep space operations themselves. My second proposal is more rooted in reality and specifically tied to some pretty hefty advances within even the last few months. Many people think of existing chemical rockets as utilizing detonations in their operation, but this is not the case. The combustion in conventional rockets is occurring at less than the speed of sound, known as deflagration. This leads to efficiency losses as the combustion and pressure wave are moving at different velocities as they exit the nozzle. Pulse rockets can achieve detonations, combustions above the speed of sound, but only in pulses. There's inherently time that the engine is not providing thrust between pulses. The rotating detonation engine, as the name suggests, creates a continuous, rotating wave of detonation that provides continuous thrust. NASA and General Electric have recently maintained RDE operations for several minutes, venturing into the realm of being a viable option for existing rocket tank architectures. Oh, and it happens to solve the aerospike issue that has plagued engineers for decades. I propose that we leverage new developments in RDE research and create scalable engine power plants to ultimately replace the engine architecture on established, reliable vehicle systems. Essentially, all the same customers exist across the light, medium, and heavy launch operations. The name of the game for rocketry is efficiency and payload mass, so I think it checks the block for both.